Golden wires and silver wires are no match for a copper busbar as wide as a finger. This is a consensus in the generator manufacturing industry. The secret lies in the production and manufacturing processes of high-power or copper brushless high-voltage generators, which are closely guarded and not passed on to the public. As the winding machine rotates, the stiff copper busbar is coiled into an elliptical winding embryo. Several turns are grouped into one circle and tied tightly with a gauze tape. Note that a slip knot should be made as it needs to be untied later. With the skills of old craftsmen, they have a muscle memory for how many times a coil of a certain length should be tied with gauze tape and where to tie it. It's all done with ease. After tying, first have a circle and then turn back, have a circle to leave a wire end for easy cutting. Fine wires are cut with scissors, while copper busbars are cut with pliers. After cutting with a pair of pliers, use a wrench to loosen the fixing screws. Currently, winding copper busbars can only be done semi-automatically, and disassembly and assembly are all done by hand. Some switch handles are short, and a steel pipe has to be put on them to be able to turn them. It's rather frustrating. There's a bit of resentment in this operation. The removed windings are sent to the winding wrapping area. Here, skillful female workers will wrap a protective layer around the winding embryo with white gauze tape to prepare for the next process. They will also remove the previously tied straps to ensure that the whole winding is wrapped properly and the tightness is uniform. After wrapping, tie a knot and cut off the excess part. Then it can be sent to the bending area. When the winding embryo wrapped like a mummy is placed in the bending machine, a new value adding journey begins. Whether it will be as valuable as gold or end up being scrapped and reworked doesn't mainly depend on whether it is placed correctly, fixed tightly, or bent to the right position. Although these are also important, the success or failure is actually determined in the previous process. Only when the gauze tape is wrapped properly and the tightness is uniform can the insulation layer of the winding be protected from being abraded. The stress generated during bending, arcing, and hammer shaping can be evenly borne and offset, so that the copper busbar won't be damaged. After bending, the copper busbar winding is initially formed. Then, a special measuring tool is used to check whether its inner diameter meets the standard. After passing the inspection, it needs to be heat and set and sent back to the winding wrapping area. Still, skillful female workers start from the middle of the end part to pick open the gauze tape and remove the middle wrapped gauze layer, temporarily keeping the two ends for further operations. Note that a slip knot should still be made at the end part because it needs to be untied later. After disassembly, it comes to the automatic winding wrapping area. Here, workers first place the undressed winding on the winding machine, then fix the two ends of the winding with two steel wedges respectively, and then start the formal winding. What is wrapped here is no longer white gauze tape. First, mica tape with fire resistance, high temperature resistance, and high dielectric strength is wrapped. As can be seen from the video, the mica tape is wrapped in multiple layers, usually 4 layers, which is equivalent to 8 layers of white gauze tape in total. Then, a black anti-corona tape is wrapped to prevent corona discharge and balance the coil potential. Strangely, in the video, two machines work together, each wrapping one side, and a single machine work independently. After that, workers manually wrap the two ends of the winding that the machines can't reach. So far, the winding is completed, and subsequent processes such as winding down and assembly will follow. Follow me for the detailed explanation in the next issue.